In this video, I'll be looking at performance analysis of a lightweight ground robotic vehicle by implementing Adaptive Neuro-Fuzzy Inference System. The outline of considering introduction, description of AGV, performance evaluation, the flowchart for ANFIS model, AGV performance rating, membership function and rules, analysis and results, and conclusion with future research. Automatic guided vehicle. Introduction. AGVs are very useful in diverse areas. They are widely used as delivery agents for material transportation in factories, in manufacturing systems, in the oil and gas system, in hospital environments, etc. Conducting performance tests on AGV has the potential to improve the efficiency and reliability of the robots. However, published studies on performance analysis focus more on traditional and classical metrics for such evaluation. But in this study, we'll be looking beyond the traditional technique and focusing on a hybrid algorithm, the Adaptive Neuro-Fuzzy Inference System. The system is battery-powered with programming capabilities for easy navigation along a specified paths. Then the mechanical design concept combines the knowledge of various mechanical parts, such as the chassis, the motor, the wheels, and other essential mechanical parts. Then the electronic concepts include microcontroller, relay module, motor drivers, and other electronic parts required for the system. The AGV is designed to trace parts automatically using IR sensors. And the microcontroller board used is the Arduino Uno. The robot is considered cost-effective, light, and very reliable. ANFIS architecture. In this study, the emphasis is on the performance evaluation of the AGV system using the Adaptive Neuro-Fuzzy Inference System. So let's look at the flowchart for ANFIS model. The metrics considered include the accomplishment of tasks based on the AGV developed, the accuracy of the AGV system, the path navigation, the energy efficiency, obstacle avoidance, and others. Then looking at the flow charts towards the right-hand side, it is important to identify the most prevalent, in terms of the metrics considered based on the objective of the AGV system. Then possibly look at the past performance of the AGV system and assigning weights to the metrics to demonstrate order of significance. Then the next is to feed the data set obtained. So the ANFIS toolbox using current MATLAB. Then the next is to properly define and fit all input membership functions. Then generate possible rules, and train, test, and validate the ANFIS model, check proficiency criteria, which mostly fits into the reviewer, and obtain the output solution. The next is performance rating of the AGV. Test variables for rating the intelligence of the robots was achieved using ANFIS model, which is implemented from the experimental results obtained. Look at the right-hand side, we have the first trial, second trial, third and fourth trial. So the data set obtained is presented herein. And there's also the performance rating towards the right-hand side that shows the AGV performance in terms of, and also the assigned points. For excellent performance, we look at the range between 81 to 100. Then satisfactory performance goes from 61 to 80. Good performance is within 41 to 60. Poor performance rating is between 11 to 40. And the very poor performance is between 0 to 10. The next is the membership function and rules. Triangular membership function as shown on the right-hand side of these slides has been used, was developed for graphical mapping of the data sets obtained during training, and rules were developed using effective alpha cuts. The membership function plot for input variable considering system performance, task accomplishments of the AGV system, the path navigation, energy efficiency in terms of battery level and accuracy is shown in the figure towards the right-hand side. Look at the membership function for the 6 input variables, input variable 1, 2, 3, 4, 5, and 6. And at the upper side, towards the right-hand side, shows the architecture of the ANFIS model. The output result obtained for the model is shown clearly here. Where the rule viewer is based on series of experimental trials. At the end of the day, we obtained, a robust solution as shown in figure. Towards the right-hand side, the output responses are represented in blue colors from the sensitivity map obtained by varying mapped data sets on the rule viewer. And the system generated good solution, which is displayed on the rule viewer by taking alpha cuts continuously. Results are obtained by varying the rulers in red color on the left-hand side of the rule viewer to give an overall rating of the AGV system in blue maps. Graphical solutions are presented also on the surface plot as shown towards the right-hand side. Yeah, so let's look at further rule viewers and results. Looking at the rule viewers, it is very clear that the rating goes beyond 70%. And summarily, for the first intelligence tests, the rule viewer showed a total intelligence system of 76%, which belongs to the satisfactory group. The second test showed a rating of 79% satisfactory. The third trial showed system intelligence result of 80%, which is satisfactory. And the fourth test trial reveals a total intelligence of 81%, which belongs to the excellent group. And the final trial shows a total intelligence of 79%, satisfactory. And finally, we got a rating of 81%, which shows that all the results obtained are quite good. Conclusion and future research. The outcome of the investigation reveals that the ANFIS model is an effective self-computing technique capable of performing total system intelligence tests of AGV with high degree of accuracy. For future study, we're currently working on the use of other hybrid algorithms for total system intelligence tests for AGV systems. And we're also looking at optimized dynamic interaction of a swarm of robots by considering a manned aerial vehicle, manned ground vehicles, and other interesting robotic systems. Yeah. The pick and drop system as well. So thank you very much for your time. I will reach out to you in the next video. Thank you.